Okay, now today we are trying to discuss thread. So to discuss thread, first of all, we have to understand some basic concepts like what is multitasking. Multitasking is nothing but doing more than one task simultaneously. As for example, you can consider that whenever I am dictating some lectures, students may listening the lecture, may also copy the notes, even they can interact with their mobile to check the time. So at a time they are doing multiple tasks. One more example of multitasking is that in case you are writing a program in C or C++ or Java and you listening some music at the same time, and also you are checking some information in the web browser. So different tasks are performed at a same time, that is known as multitasking. Next, multitasking can be divided into two parts. One is process-based multitasking, one is thread-based multitasking. What is a process-based multitasking? There are different types of programs are running simultaneously to form the concept of multitasking. Like I gave the first example where we write a program in C, C++ or Java, we listening some music in some app, we can also download some information from the web browser. So there are different types of programs are there that is running simultaneously. That is a form of multitasking. But in case of thread-based multitasking, one single program is there and this program can contain multiple threads, each thread performing different tasks simultaneously that can enhance the throughput. That means if I am doing different work using different threads parallelly, it may be the total time required to complete a task is less if we divide each work and complete differently using programs. So in programming point of view, we should go to thread-based multitasking. Fine. So next, what is a thread? So thread is the execution of flow or independent execution of a flow. Like in the picture, you can identify that. First of all, there is a single path or single flow of execution, that is a single thread. Next, if we want to create more than one thread, it will be called different flow of execution and also multi-thread. So thread is nothing but separate execution of a flow. You must understand that thread may be different, but the program is single. Next, so in the case you think there are two options are there, that is thread-based multitasking. Why we need thread or multi-threading? You can understand with a basic example. Suppose a client, a software client, want to do different tasks using some programming constraints. they are asked the software developer to develop the program in a module. So whenever this type of task is assigned to a software developer, they must go for thread-based multitasking, or you can also call the approach is known as multi-threading. Why? So whenever the software based requirement is there, you can think of the requirements are software based, so no need to going to the OS level. But in case of process based multitasking, you can think of, in the example, I am writing a program in C++, so it is programming level. But whenever I am listening some music, I download some information through the web browser, it is the OS level. So no need to consider OS level separately. When there is a task of programming related, it is mandatory to use multi-threading. Clear? So next we concentrate about how to implement a thread So there are several ways, there are two ways to implement a thread. First of all, we look into implementation of a thread using thread class. And we have to know the methods of thread class. Another way to implement multitasking, that is implementing the runnable interface. Now we are going to have a very basic way to create the thread. For that, some basic syntax is also required. Like you can find that there is a class myThread that extends thread class. Next, you have to write public void run, then some code inside the run method. So this run method must be written into your class which extends thread. So before going to details of this programming, we concentrate about this run method. So what is this run method? This run method is defined in the thread class, and we are overriding the run method. Actually, the run method is the heart of the thread, or you can say that the task performed by a thread is defined in the run method. So the task performed by a thread is defined in the run method. You can see that the codes are written in the run method, and that is the job of the thread. So whenever we want to implement a logic or a new task in a thread, we must write our own code inside this run method. In this example, we are just writing a simple for loop to print some numbers, and That is the task of the thread. Task or job of the thread. Okay. Next. If we start the thread, the job is performed written in the run method. Okay. So to define a thread, we use this code where we create a class that extends the thread class, and we have to write some code in the run method, which is the actual implementation of the thread. But this is not the end of the code. Some separate code is there to complete this example. So what is that? Now, after writing this class definition of thread, we have to create some thread object. What is that? So we are writing a new class tst thread, and inside public static void main string s, we have to write our thread class object, or we have to create the thread class object t1 to initialize the thread class object, and that is started by the main thread. So to create the thread class, I have to write my thread t1 equal to new my thread and first bracket open close semicolon etc. So after you write this statement, the thread class object is initialized or created. In this example, you also consider some flow of execution. What is that? Whenever you are starting with this main method, there is a single flow of execution, but you have to create a new thread. To do that, you should write thread object dot start method. This start method is used for creating two different flows. One is for main method, one is for child thread. So at this point of time, there will be two threads. Until and unless you are specifying t1.start, there will be one execution flow. After t1.start, there will be two different paths will be there. One is followed by the main method or main thread, one is followed by your child thread. Clear? So t1 next, so this statement creates the newborn state of a child thread. This statement is used to ready or is used to make the child thread ready or runnable state. Clear? So right after this point of time, there will be two threads. One is main thread, one is child thread. Before this, there will be a single thread. Now, you consider one more thing is that we are not writing t1.run. Clear? So have a look in this, that we are defining a run method inside our thread class, but we are not calling this run method explicitly. So the start method will invoke this run method. The start method will invoke the run method that is defined in the thread class, and after that the output will be printing of some numbers that is written into the code. So to create a thread, you should define the implementation of a thread by extending the thread class and creating a separate class that is myThread. Next, you write the code to perform the job of the thread into the public void run method, and after that you should create the main method using a different class that is tst_thread, and then you create a thread object or thread class object that is t1, that is of myThread, and after that creation of the thread object you should write t1.start. It is mandatory to start the thread and also invoking the run method. Okay, myThread t1 equal to new myThread is responsible to creating the newborn state of the child thread, and t1.start is required to create starting the thread invoking the run method. After t1.start there will be two execution flows. One is for main thread, one is for child thread. But if you are not writing t1.start, there will be one thread. Okay. Now come to the difference between t1.start and t1.run. So in case you are writing t1.run instead of t1.start, no new thread is created. Main thread will call run method as a normal method call. So if you are not writing t1.start and you are writing t1.run, the method run that is defined in your thread class will be called as normal method call. And in case of t1.start, if you are writing t1.start, at that point of time two threads will be created. One is main thread, one is the new child thread, and perform the job. So you must write t1.start to creating the child thread and to perform the specific job that is created inside the child thread. So that is the difference between t1.start and t1.run. Now we are going to discuss a new example of creating 3 threads in a single program. To do that, you have to create 3 thread class. First of all, you create a thread class that is thrd1 extends the thread class that is defined in the system, and you should write public void run in the case of the class body to implement the job of thread 1. Next, in case of class 2, that is thread 2 named as thrd2 extends also thread class, and you write a new for loop that is dependent upon the value of j, and it will also printing the value of j along with thread 2 is running. So this is different implementation of 2 threads. One is printing the thread 1 is running as well as the I value. Next one, thread 2 is running as well as the j value. And obviously in the case of thread 3, it will be the variable is changed with the name as k, and it will be printing thread 3 is running along with the k value. To create the thread, we should write, or we should create the thread object differently, and we have to call the start method to invoke the public void run and for running the thread. To do that, we write our main class, that is tst thread. Under that, I am writing public static void main string args, third bracket open close, and then the first thread object, that is th1 of thrd1 type. This is the instantiation of the thread object th1, as well as we write th2 as a different thread object and th3 as a different thread object. After creating each thread object, we have to start, or we have to invoke the run method with the help of the start method individually. And after writing 3 different start or the 3 thread object along with this start method, we can have the actual output in a order or in a execution order. So you have to save this class or the file. You can think of the file name is tst thread, that is the class name, and you go to the command prompt and write javac tstthread.java and compile this program. And after that, you write java thread tst thread, and the output is like that. Thread 1 is running, thread 2 is running, thread 3 is running, thread 1 is running, again thread 2, then thread 3, likewise. So this is the actual implementation of the thread, and these 3 threads are simultaneously running, and you are printing these different values or different tasks performed by the 3 threads. So this completes the first way of implementation of thread using or extending the thread class.